Chris Goodin. I'm a researcher at the Center for Advanced Vehicular Systems. So I'm from Vicksburg, Mississippi. I grew up in Vicksburg, and I did my undergraduate degree at Mississippi College. I got a double major in math and physics. And from there, I went on to Vanderbilt University and got my PhD in physics. But when I graduated with my PhD, I ended up getting a job at the Engineer Research and Development Center in Vicksburg. And that was when I really got into studying ground vehicle autonomy. That was in 2008, and the Army was really starting to study and invest in autonomous ground vehicles for the military. And I got involved in writing simulations for those autonomous ground vehicles. And so that's how I really got started in the field that I'm in now. I've worked at Mississippi State almost 4 years. It'll be 4 years on November 1st. For a subject like autonomy, it's not something you can do alone in your office. It's something you need a big group of talented people to work with for anything that you want to do to really bring it to fruition. It's a really great group of researchers that I can be a part of that are really good at their jobs and talented in their field, and also just a really nice group of people to work with. So at CAVS, I work in the Advanced Vehicle Systems group. And one of the things we study is ground vehicle autonomy, or what a lot of people call self-driving vehicles. So a lot of people have probably heard of Tesla and companies like that that are making self-driving cars. But specifically, we're interested in self-driving cars that can work in off-road scenarios. And those are the kind of things that a car like Tesla really uses to help it navigate. In an environment where you don't have that, how can you make a vehicle, still go where it needs to go if there's no driver? And I specifically work on simulations of that. One of our biggest customers is the United States Army, because they would like to be able to have self-driving vehicles that can work in all types of different terrains. The main thing that I work on is the Mississippi State Autonomous Vehicle Simulator, which is a simulation tool for autonomous ground vehicles that does the sensors on the vehicle, so that could be cameras or something called LiDAR, which is a laser rangefinder, radars, automotive radar. It simulates the vehicle itself, and it simulates the environment or the digital terrain that the vehicle operates in. I would say the overall goal of what I'm doing, and a big part of what we're doing at CAVS, is to help push the entire field of off-road vehicle autonomy forward. And we do that in a couple of different ways. One is to understand the best ways to measure the performance of autonomous systems. But one thing that hasn't really been determined is how can we actually understand when those systems are good enough? It can be very hard to discover what those failure modes might be, or detect what causes a system to fail. So one of the big overarching things that we're studying, and we're using simulation to study, is ways to quantify the performance. Unlike manned vehicles or human drivers, there isn't really a standard set of tests or metrics that go along with those. And so we're using our simulation and our expertise of autonomy to help develop those tests and metrics to quantify autonomy. On the flip side, we're also using our simulation, our expertise in autonomy, to develop autonomous systems. So we're developing self-driving, off-road self-driving vehicles here at CAVS, and we'll use the simulations that I've worked on to help test those and understand how to make those work better before we put it on the real vehicle. And then even as we have it on the real vehicle, to keep iterating and improving the autonomous systems. There's researchers at about a dozen different universities around the country, and actually around the world now, using MAVs. So we have several international users. We have about half a dozen government organizations in the Department of Defense, Department of Energy, using MAVs to study different things about autonomy. I think one of the biggest challenges in developing any software that other people are going to be using is supporting the needs of your users. Doing this kind of work in 2008, what was important to software users then is very different than what's important to users now in 2021. I mean, the field has changed a lot in that time. And so being constantly responsive to what our users want the software to do has probably been the biggest challenge. I think the people. Rather than a spirit of competition, there's a spirit of collaboration, working together to solve kind of hard research problems. And I think that's ultimately a very fruitful way to tackle these kind of research questions.